Hey everyone, welcome back to Code Stick Daily. In today's Leetcode problem solving, we'll be tackling a common problem often asked in coding interviews actually. So the problem is, can you divide an array into pairs such that the sum of each pair is divisible by a given number k? Sounds some kind of tricky, right? Don't worry, I'll walk you through it step by step. First, let's see what's been given in the question. So we need to check if array pairs are divisible by k. So it's actually a medium level difficulty problem, and it's given an array of integers array of length n and an also integer k. So we want to divide the array into n by 2 pairs such that sum of each pair is divisible by k. So we are going to divide the array into half of the array pairs, right? Okay, that means if there are 10 elements, then we need to form 5 pairs. So here we have an array 1 2 3 5 10 6 7 8 9 and given an integer 5. The output is true. Okay, let's see. So the pairs forming are 1 and 9, and the sum of those sum up to 10, and it's 10 divisible by 5. Okay, done. 2 and 8 sums up to 10 and it's divisible by 5. 3 and 7 sums up to 10 and it's also divisible by 5. 4 and 6 also sums up to 10, it's divisible by 5. 5 and 10 sums up to 15 and also divisible by 5. That sounds great. Okay. So we also have 2 and 3 that also sums up to 5, but I don't know why he hasn't, I mean, why they haven't given the explanation. So let's take another example. We have a array 1, 2, 3, 4, 5, 6, and the integer we given is 7. So as there are 6 elements, we need 3 pairs, and 1 and 6 form a pair, sums up to 7, divisible by 7. 2 and 5 form a pair, sums up to 7 and divisible by k. Good. And 3 and 4 form a pair and sums up to 7 and also divisible by k. So the output is true. Now we have another example. Same 1, 2, 3, 4, 5, 6 the array, and the k equals 10 and the output is being false. So you can try all possible pairs to see that there is no way to divide array into 3 pairs, each with sum divisible by 10. Yeah, that's true. You see, and there is a one pair only that sums up to 10, that is 4 and 6, that pair sums up to 10, but we will be having only one pair here. So the length of the array is actually 6, so we need exactly 3 pairs to provide an output true. So there are constraints here. Array dot length is equals to n, and n is always even, and 1 less than equals n less than equals 10 power 5. Okay, so we need to understand it actually. Okay, the problem is simple but kind of tricky. Okay, so firstly we need to understand pairing with the reminders actually. So the key to solving this problem is to focus on reminders when dividing numbers by k. Okay, let's take an example here. For example, let's take the number 9 and k equals to 5. Okay, so when we make 9 modulo 5, the output will be 4. Now if you find another number in the array, say 1, okay, say 1, and it also gives the reminder 1, because when we say 1 modulo 5, it equals 5, sorry, it equals 1. Okay, we can pair them up because 1 plus 4 equals 5 and is also divisible by 5. So the idea is simple. For every number with a remainder r, we need another number with remainder k minus r to form a valid pair. Okay, but what about some special cases also? Let's take a look at them. Okay, there are two special cases to keep in mind. So one is about the remainder 0. If a number is divisible by k, it will have a remainder of 0. Numbers like this can only pair with the numbers that also gives a remainder 0 only. So we need an even number of elements with the remainder 0. And the second case, remainder k by 2 for even k. That means k equals an even number. If k is even, any number whose remainder is exactly k by 2 can only pair with another number with the same remainder. Okay, so these are two special cases we are having with this problem, and now let's move to the coding part. Okay, now we'll use a dictionary to store the frequency of each remainder when dividing elements by k. So this will help us check if we can pair all numbers properly or not. So let's get started with the Python code. So before that, I want to um, import a library here from collections. I'm going to import from collections. I'm gonna import default dict. Okay, I'm gonna import the dictionary here, and now I'm gonna take a variable called reminder count. Reminder count, and I'm gonna initialize it with the dictionary. Okay, default dict, and it only consists of integers. Right. Okay. So create a reminder frequency dictionary is successfully done, and now we're going to calculate reminder for each element. Okay, let me take a for loop for num in array, and now we'll take a variable reminder, and reminder equals num modulo k. Okay, num modulo k. So we need to ensure the reminder is always positive. Okay, now if reminder is less than 0, so in this case we gonna add reminder, sorry, reminder plus equals k. Then reminder underscore count, so the dictionary reminder underscore count of reminder. So here the reminder is going to be the key here, and we are just incrementing the value by 1. So now first, let's see what we have written here. First, we are using a default dict to store how often each reminder appears, and for each number in the array, we are computing its reminder when divided by k. So if we get the reminder as negative, we adjust it by adding k to make it positive. Okay. Now we are going to check the pair conditions. Now that we have all the reminder counts, we can check if pairing is possible or not. So let's write the code for that also. Let's take another for loop for check if the pairs can be formed or not. So I'm taking a variable rem in the dictionary. Okay, I'm gonna traverse the whole dictionary. If rem is rem equals to 0, for reminder 0 we need an even count, right? So if reminder underscore count of rem, we need to check whether it is even or not. Modulo 2 not equals to 0. So in that case, we are gonna return false. Else, else we're gonna return for each reminder rem, there must be a matching count for k minus rem. So else we need to check another condition, that if reminder underscore count of rem, it's not equals to reminder underscore count of k minus rem. Okay, then we are gonna return false again. Then we're gonna return false again. We're gonna exit the loop completely and write the return statement as true. Now let's see whether this runs or not. Oh, okay. I think we might have missed somewhere. Okay, let me check again the code. Where did we go wrong? Hmm, I think, okay, there is one test case passing. Okay, only one test case is being passed and the remaining are false. Okay, let's see where did I go wrong. Um, okay, from collections I have imported, that's working fine. And I have initialized a frequency dictionary, okay, for nomin array. Okay, for reminder equals to num percentile k. Okay, then I'm checking if the reminder is less than 0. I'm just incrementing it with k, and then the reminder of count with reminder. I'm increasing it to value. So I'm checking if the pairs are possible or not for REM in reminder underscore count. Okay, if REM equals to 0. Okay, if REM equals to 0, and if REM reminder underscore count of REM modulo not equals to 0, I'm just returning false. Okay, okay, I just need to write this else condition to the outer if, not the inner if. So this should work, I guess. Let me run. Yeah, it's working now. Let me submit the code. Let's see. Working perfectly fine, and the runtime is 500 milliseconds, and it beats 46.77% users. So pretty great. So let's recall what we have done in the code. So firstly, we have calculated the reminders. We first computed the reminder for each element in the array and store the frequency of each reminder in the dictionary. So if a number gives negative reminder, which can happen with negative numbers, we adjust it by adding k to ensure there will be all the positive numbers or positive reminders. And then we have checked for the pairing conditions. For reminder 0, we check if its frequency is even, because numbers with 0 can only pair with each other. For other reminders, say REM, we can check if the frequency of REM matches with the frequency of K minus REM. If not, we will return false. And then if all the pairs satisfy the condition, we are going to return true. So the time complexity for this problem or the code that I have written will be the order of n, where n will be the number of elements in the array. We traverse the array once to complete the reminders and check the pair of conditions, right? The pair conditions, and space complexity will be order of k for storing the reminder counts. So this approach ensures efficiency while solving the problem in linear method, and that's how we solve this problem efficiently with Python. So if you found this video very helpful, give it a thumbs up and don't forget to subscribe to CodeStreak Daily for more coding tutorials and interview preparation videos. So if you have any questions, feel free to drop them in the comments. Thanks for watching guys, and I'll see you in the next video tomorrow.